Okay. Let's say SAT and ACT. Let's say you took both, and you know the average of SAT is 500, and average of ACT is, let's say, 22. Okay. Or 24, make it. Okay, and standard deviation for SAT is 100, and standard deviation for ACT is 5, right?
Okay.
Okay, let's say you took both tests, okay, and you got 700 in SAT, and let's say you got 33 in ACT, okay? And you're thinking, okay, which one should I send to the college? Let's say you don't know the percentile, okay? You want to send only one, the higher one, okay? You don't want to send the lower one. So how do you find out which one is better? You can figure out how many standard deviation above it is, yeah? So here, you can see that it's going to be 700 minus 500, is 200, divided by 100, you get 2. This is going to be 2 standard deviation above. You do the same thing for ACT, you can do 33 minus 24, that's 9, divided by 5, 1.8. So it's going to be 1.8 above. So that means this SAT was better. Yeah?
Oh, yeah. Okay.
That's what. Make sense? You got to send SAT to the college. Okay? So also, there's one more thing you need to understand, and that is within one standard deviation, let's say 600 to 700, 500 to 600, you'd have 34%. Okay? And 600 to 700, that's 2 standard deviation. 34% this way also, that's 400. Okay? And then 700 to this is about 13.5%. Okay? So another 1 standard deviation, that's 300, would be another 13.5%. Okay? So that's like basically is 95% within 2 standard deviations, right? And if you go one more standard deviation, it's about 2.35%. Yeah. I'll need that for your master's statistics anyway, so might as well just memorize it, you know.
Okay.
Okay.
All right.
And then 0.05, 0.15, 0.15%, 0.15. So anything below is 0.15%, right? So it's like.
And so it's always like that.
Yeah, that's what it is in normal distribution. Okay.
Okay, that's a normal distribution.
When it looks, when it looks normal, you might want to take a screenshot of this. Just make sure you get this clearly.
Okay.
Different types of standard deviation questions are based on this, and some of the standard deviation goes crazy hard. You know.
Yeah.
Just it's really weird. I don't know why they even have it. So okay, let's move on. Let's try number 6. Go ahead and try it.
Okay. Only a certain population. 30 centimeters. Standard deviation of 3. One of the worms is picked at random. Probability that the worm is between 24 and 30 inclusive. The probability the worm is 27, 30, 30. So 3. So standard ratio. So 1 standard ratio. 34%, 33, 27. Okay. Okay. 30. Okay. Equals 27 and 33. 68%. B's higher.
You got B? Yeah, B is right. Make sense?
Yeah, because there was a 68%
Hang
chance for
I
that.
was thinking yeah, yeah. Should I explain? What do you think?
I think I got it. I picked B because it was 68% and A would only be 47.5%. Because it's
Yeah,
with
yeah, you're right. You're right. Right. You can even look at the picture and tell, even if you forgot the numbers.
Yeah.
But I like the way you calculate. That's the right way to do it. Okay? So you see that average is 30. Okay. And 24 is like down here. Okay?
Yeah.
And then on the right side, you can kind of see that this zone. Okay.
Yeah.
This is 33. So let's say the green zone here. I mean the yellow zone here, and the blue zone here. Okay?
Yeah.
Notice that the green zone is kind of like in both, right?
Right.
Both of them have the green zone. See, the yellow zone is higher. Just by looking at it, you can tell. That's so much closer to the mean. So even if you forgot your numbers, you can kind of use your common sense and figure that out, right? Cool. Let's see, number 7. Yeah, go ahead and try number 7.
Okay. Okay, so the number of homeowners is greater than 112. So 11. 101. It's another 11. 13.5. You have 34, 13.5, and then what was above 2 standard deviations? One standard deviation is 34, 2 is 13.5. What was the third percent at the end of the ends of the curve?
Okay, let me show you here.
I didn't write it down because you started recording it. Sorry. I usually go back and watch these again and then I take notes. I just watch you do it first. So, okay, so it was what?
So the standard deviation is 1100 and the mean is 90,000. So
Yeah, I'm drawing it out right now. One standard deviation would be 90 to 1.
So 112 is like 2 standard deviation, right?
Yeah, it's above 2.
0 to 2, right?
Yeah.
So now, how many are within that 47.5%, right?
Yeah.
Okay. So only 2.5% is above, right?
2.5. That's where I was looking for the number.
Right.
Okay. Yeah.
Yeah.
So
2.5 times 8,000 is what? 8,000 times 2.5 is 20,000. Okay?
Yeah. So quantity B.
Oh, sorry. I'm saying 0.025 divided by 100.
Yeah.
Okay. So 200, right?
Yep.
That's
so B is greater.
Less than 3,000. Yeah. B is greater. Is that clear?
Yeah. I just forgot that 2.5%. I remember the others.
Yeah. Yeah. So because you can you can do like this: 50% minus 47.5. Okay, that's 2.5%.
Okay.
Like that. Okay. Let's try number 8.
Grades, one students in this question class. is equal to 77. Percentile. If you're in the 50th percentile, is that the mean basically?
50th percentile is always the mean, yes.
Okay, all right.
Well, if it's not skewed, if it's skewed, it's different. But for example, this
is a normal.
Here it's not,
curve. Yeah.
But if it's symmetric, then it's a mean.
Yeah. Okay. Gotcha. So,
another thing is this thing is called the right skewed. Okay. So in these cases, the mean will be above the median. So let's say median is here, 50th percentile. The mean is going to be above. That's because like somebody who got, like let's say Bill Gates will increase the average all by himself, like long tail, like that.
Right.
Or if it's like if it's the other way, let's say the age of like life expectancy of all your friends, if somebody dies early for accident or whatever, by himself is going to bring down the average a lot, right?
Sure.
So the median is going to be like high because most of them are like 50th percentile.
Yeah.
But the mean is going to be lower than median. Okay. Because one person can bring it down a lot,
Okay, I see.
Yeah. So that's how you can see the relationship. Again, you'll need this in your master's probability statistics class also. Okay, try number 8.
Yeah. 77. The number of students who scored less than 80 on the exam. And then the number of students who scored greater than. B is going to be greater, right?
B? No, I didn't get B.
Okay. I only picked that because, okay, I don't know. Is it D, unable to tell?
No, it should be C. Let me show you why.
Okay.
Okay. So 77 is right in the middle. You can tell, right? Easy to tell. Okay. 77. So
Right.
the Z score, the standard deviation, the Z score is called. The standard deviation, how far it is from standard deviation is 0. The percentile will be 50%. I tell my students to actually make 3 rows here, so you don't mix it up. Percentile Z, and Z is like how many standard deviation away from the mean. Okay? So this is what the question gave us. Okay.
Yeah.
The number of students who scored less than 80. So 80 is going to be just 3 more than that, right? And 74 is going to be 3 less than that. So think about it. More than 74 and less than 80. If it's symmetric, should be exactly the same.
Right. Okay.
Yeah?
Equal.
Make sense?
Yeah.
Yeah. Let's look at question number 9. Go ahead and try it first.
Link the bolt to manufacturing.
Let me make it bigger. I'm just copying it to the notebook. Yeah, go ahead.
I'm gonna say C, but let me see. It's 68%. Four. So 1, 4. Uh, 4, 2. Over 2, and then that's 2. 34, 13.5%. So 13. 42. 42. Is it not C?
I got D for that.
Yeah.
This is why.
It's taking me longer.
Mean is 1630, standard deviation 0.0084. Huh?
Right.
So you need to draw a picture. The mean is right in the middle. 0.1630.
Yeah.
The Z is square 0 and the percentile is 50%. Okay. And then you can see if you keep on adding 84 to this, this will be 17.1714, and one more you get 0.1798. So you 1 into this, you do like this. Okay, and then the so this one is 15, 17. They're talking about point that's like in between those two. Okay?
Yeah.
And then the other one is supposedly the other one is 1546. You have to go left. If you subtract, it's 15. 44. Okay, 46. Yeah. So the easiest one to tell is, so we are looking for this left green point, which line this one, right? Which
Right.
is exactly in the middle. 1756, if you calculate it, you're right in the middle, 1756. So this is the 1.5. Okay?
Yeah.
Now, we don't know that. We don't have that memorized. Okay. But what we know is this group has 68, right? So we already know it's going to be more than 68. So we know A is wrong. We know B is wrong, right? Get it?
Yeah. I do get that.
Now, okay, so those are out. Now, the question is, see this part right here is another 13.5%, right?
Right.
So if the whole thing was it, then you'd have 68 plus 13.5, that would be, what is it? That would be 81.5, you know? So you automatically know E has to be wrong now, right? Because we don't want the whole thing. We only want
Yeah. In
up to
between.
here, right? This,
Yeah.
this yellow one, yellow extra one, right?
Right.
Okay.
Mm-hmm.
And it was right in the middle point. Do you think it's going to be 6.75 and 6.75 or no?
What'd you say? Right in the middle. What?
Do you, yeah, because if you divide 13.5 by 2, it's 6.75. Do you think it should be split between 6.75 and 6.75?
I'm not sure what you're asking. I'm sorry.
It shouldn't. It shouldn't, because
Yeah,
you got a yellow
lower.
zone and the blue zone. Blue zone is much smaller, right?
Oh, yeah, yeah.
So you can automatically tell this is going to be big, this is going to be small, right?
Yeah.
So this 13.5 should be 6 points. Should be. So you have to decide whether it's between 62 and 81. Is it going to be 75 to 82 or 68 to 75? Okay. It has to be the fourth one because it's going to be bigger. You got the bigger part. Okay.
Okay.
It's going to be at least 7%, you know?
Yeah.
Out of the 13, it's 7, 8, 9% or something, you know? So it has to be D. So even if you don't know the exact value, you can still tell using your common sense.
Right.
But, you know?
Okay.
Okay.
Yeah.
All right. Try number 10.
I'm not sure how to do this, but I'm just guessing that it's going to be either A or E.
Okay. Actually, it is E. Okay.
All
So
right.
first, you have to see what is the median? Median is right the middle point, -1. -1. So you automatically know C is out. Okay.
Yeah.
Okay. The middle of D is also not -1, so that's also out. Okay.
Yeah.
B is out. Just with median, you can throw those out, right? And this one is median is right in the middle. Median for this is right in the middle. So those are correct, okay?
Yeah.
For A and E. Now let's look at the right side. 75th percentile is this, okay? And 25th percentile is this. That's how it's done. You know?
Oh,
so
that's what
this is the max, and this is the mean, okay?
Okay.
So max and mean are same for both A and E. So that didn't help us. Those didn't help us, okay?
Yeah.
The max and mean were the same, so we still cannot figure out what should be the right one. Now let's look at maximum. Maximum should be 0. I'm sorry, not maximum, 75th percentile. So for A, 75th percentile is 0. For B, 75th percentile should be right in the middle of the right side, which is also 0. So that didn't help us either, okay? And let's look at the 25th percentile. For 25th percentile, the left is -4. And right there, we know that cannot be the answer, okay?
Right.
Because E is the only one alive at this point. But if you want to do it, you can do the middle of the left side for E, and that's -3. So that worked, okay?
Yeah.
-3. -3, there you go. So that's the only one that's still alive, right? So you have eliminated all 4, right?
Yeah.
Make sense?
Yeah.
Cool. Try number 11 then.
Interquartile range. I know that's something I saw in statistics, but I don't remember what that meant. Was that this the regular range? Interquartile range. Five, 10, 15, 20, 25. Be 20 minus 10. I don't know. I don't know what interquartile range is.
So,
oh wait, I'm gonna
first
guess.
10 positive multiples of 5. First, no, don't guess. Let's learn. The first 10 positive multiples of 5. That means you're talking about 5, 10, 15, 20, all the way to 50, right? That's what you're looking at.
Yeah.
So what's the interquartile range? First of all, you need to find out what's the median, okay? So the 25, 30. So you know that between the 5th and 6th one, you have the median, okay? Let me write the whole thing, actually. It'll be easier for you to see. 35, 40, 45, 50, right? These are the 10 values, right?
Yeah.
So the median is going to be exactly 27.50, but we don't need that. I did that for you to see. Is that clear?
Yeah.
Now from the middle, you have to look at the right side. And what's the middle of the right side? The middle of the right side also includes 30. The middle of the right side is called Q3, 40. And middle of the left side is Q1,
15.
and that's 15, right?
Yeah.
So all you need to do is take this 40 and take this 15 and subtract, because it kind of gives you an idea of how spread out the number is, you know,
25.
interquartile range.
Yeah.
Get it now?
Totally.
Okay. So 40
minus
minus 15 equals to 25, and that's all you need.
Okay. Yeah.
Cool. Let's see. Yeah, try number 12.
Okay. Give a math test with the maximum possible points. The vast majority is.
Okay.
A square for 0, perfect score, or 0. Indicate all such statements. I know A is one of them. I would not equal the mean is not equal to the median. I don't know if that's necessarily true. B, the range of data set T would be significantly smaller if scores had been more evenly distributed. I'm gonna say A, just the first one.
Okay. Yeah, you're right. Is that clear?
Yeah.
Okay, cool. Let's move on then. To try this one, number 13 starts at the top of the page. Let me copy this to the notebook.
Okay.
Here. Starts here. Ends here. 14 starts here. Ends here. 15 ends here. 15 here.
Um, 68th percentile. Second. Mm, 16. We'll say A is greater.
Okay. I don't get that.
Okay.
Let me show you why. Draw the picture very clearly. See, she is in the 68 percentile. So 68 percentile is going to be somewhere on the right side, right? Okay. And 32 percentile is going to be
on the left.
Somewhere on the left, right?
Mm.
And notice that they're from 50, they're like plus minus 18. Okay. Okay, so they're symmetric, actually, equal distance from the middle. Get it?
Yeah.
So below 68 and above 32, what numbers do you get?
Below 68 and above 32.
I mean actually this is the other way, right? So Jane is this one. Greater. So this is above 68 and below 32. So the answer for this one is 32. The answer for that one is also 32.
Oh, okay. They're equal. Okay.
Right.
I see.
Make sense?
Yeah.
14.
Okay.
See, these kind of questions you really need to get trained, because otherwise you will like staring at these questions for hours, and this
Yeah,
type of
you have
questions
no idea.
trying to understand what's going on. Yeah.
Yeah. A class of 28 students scored only on average of 10. At least one student got every possible score, and the average was 7. Okay. Every possible score. Okay. Score that could have been received by more than one student. I don't know how we could find that out, but is it D? I mean, I know the mean is less than the median, but
You can tell.
you can.
Here's why. Yeah. Okay. This is actually very, very, very difficult question.
Very difficult.
Very hard. Yeah.
Okay.
So first, you see that's 20 students. Okay.
Yeah.
And they got 0 to 10. And at least one student got
10.
every
Shit.
possible scores, right?
Yeah.
So you're talking about 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 11 students, right?
Yep.
Yeah. So we still have 9 more, okay?
Sure.
We don't know much about those 9, okay? Then there's one more clue, that is average is 7. So if the average is 7, average times count equals to sum. So that's how you know that it must be 140. Yeah. Right. So we know all of them together got 140. So first you need to find out what's the sum of this. Do you know how to find the sum of this series?
No.
Okay. The sum of series is, the formula for sum is A1 plus AN, the first one and last one. It looks harder for you to think. First, okay, plus last, divide by 2. So you get the average of them, the first one and last one, because they're spread out evenly, okay? Once you know the average, okay, take the average and multiply it by the count. So when you do that's 11 over 2, that's 5.5, right? So multiply by 10, so that's 55. So basically these 10 had a sum of 55, right? Not 10, this 11. This 11 is a sum of 55. Make sense?
Yeah.
Okay, so now we know, we have to think like a detective. See all the clues they gave us, what can help us get what? So now we know the sum is 140. We know those 11 had 55. So you subtract those 55. What do you have? 85. Okay?
Uh-huh.
So at this point, you look at this and you say, okay, I know that those 9 got really high score, 85. Okay?
Mm-hmm.
We just don't know who got what, right?
Yeah.
You with me so far?
I don't get the last thing you said. The 9 more 80 and 85. What's that?
Because the total score for all 20 was 140, right?
Okay. Yeah.
And the total score for those 11 we know was 55.
Okay.
Okay?
Yeah.
So the other 9 must have gotten a total of 85 points. That's the only way this could have been 140.
Okay. Yeah.
Is that, you see the logic?
Yeah. I get that now. Yes.
Cool.
Mhm.
Okay. So everything is clear so far, right?
Yeah.
The next step is just a little bit abstract here. So it says the lowest possible score that someone could have received in this group of 9 people. Okay.
Okay.
You want to give somebody very low score. Okay.
Mm-hmm.
So there is, so the best way to do this, give 8 of them 10. That's 80.
Mm-hmm.
Okay. So if you
Yeah.
give everybody 10 except one person, you want to just give him a low score. You still have to give that person one more, a 5, right?
Uh-huh.
Get it?
Yeah.
If you gave that person a 4 or a 3, you could not have, they couldn't have 85 out of those 9 people, right? Impossible. So this one is actually 5, which is more than 4.
I see. Okay.
There's
Wow.
so many different concepts put in together, you know?
Yeah.
A little bit of series, a little bit of, you know, a lot of logic, you know?
Yeah. Mm.
Okay, a little bit of rate, average times count is sum, things, you know, so you really have to use your brain for this question. Okay?
Yeah. I see that.
But the good thing is if you get this right, the computer is going to get your score way up, you know?
Oh, wow.
then you'll get really hard questions. So the computer is like, whoa, well, that's okay. If you get a really hard question, that means you're doing great. Okay? So even if you make mistakes, the computer will still, you know,
Yeah.
keep you up. So it's okay. So don't be scared if you get a really hard question. That means you're really, you know,
Right.
getting, you know. All right, try number 15.
Okay. It's that noise. What's that noise?
I don't hear anything.
Sorry, it's on a someone's making a drilling noise. Is it outside?
I didn't hear any. Yeah, I didn't hear anything. It's probably on the
Okay.
internet or something.
All right. Okay. Sorry about that. It's over at our house. It's our neighbor.
Okay.
5 quintile groups. Students are not told their scores, but only their quintile group. The scores of 2 students in the bottom quintile group chosen at random and added together. The score of the student on the top chosen at random. I'm just going to guess B is greater. Of 100. 18 of 100. I don't know. This is ridiculous. These are hard to me. I'm going to say B, but I don't know how. I'm just guessing.
Yeah, let me try to do this one. Okay. So it says 5 quantile groups. 5 quantile groups means 5 different ones, right? Okay.
Right.
So, oops, this thing. Yeah. So, really looking at, okay, 0, 20, 40, 60, 80, 100. Okay, that's what you're looking at, right?
Okay.
They're broken, right? Okay, so they can only know their quantile group. They don't know the score, okay? So, 2 students in the bottom quantile group and versus student in the top quantile group. Let's say someone here, okay?
Yeah.
So that's what you're comparing, the total of the left two. Now the thing is, maybe everybody got A, you know? The lowest person got 90 and 90, highest person got, I don't know, 100, you know?
Yeah.
So in those cases, what happens? The left side is bigger, okay? Get it?
Yeah.
So somebody in the top quantile, okay? Make sense? So somebody in the top quantile group could like the, you know? So you can see left is bigger. But if it's the other way, let's say it was a really hard test, you know? Let's say in the lowest quantile group, somebody got 25, somebody got 30. In the highest quantile group, somebody got 80, you know?
Yeah.
So in this case, the right is bigger. So the answer should be D. Because you could go either way. Okay.
Okay. I see. Yeah.
See, a lot of these types of questions, D is like the default answer. So you start with that. Okay.
Yeah.
Even before you know, see what's possible and not possible, you start with D as if D is what you're, you know, looking for.
Yeah. Okay.
Okay. All right, let's start with this one. Try number 16.
16.
Yeah.
$10 million. 1 percentile would represent what percent of the total number of terms? Is it B?
No, it can be.
What percent of the total?
So this is a very straightforward question. There's no trick in it.
Yeah.
Just 1%. 1 percentile will represent 1%. Any percentile will represent 1%. So if 99 percentile, is also represent 1%. Any percentile has 1% in it. Is it?
What? Wait, 1 percentile, like when you just make it 1% of 10 million or no?
1%, no. What it's saying is what percent of the total number of terms? Any percentile represents 1% of the whole thing.
Oh.
That's all it says. It's E. So if somebody says 75th percentile represent what percent of the whole thing, you'd automatically say it's 1%. It's just talking about 1%.
Oh, it's always a 1%, no matter what. Okay.
Yeah.
Okay.
Here?
Yeah.
All right. Try number 17.
Okay. What is the range of the data set of numbers comprised entirely of 18? Wouldn't it be just 19D?
Dog? Yes, you're right. Good. 18?
Okay. A particular test whose scores are normally 2nd percentile is 1720, while the 84th percentile is 1990. What score rounds in this chart? 10th. Mostly closely corresponds to the 16th percentile. Okay. 16%. Okay, I don't know. I'm stuck. I drew a bell curve. 1990 is 84 percentile. I don't know. I know 34% scored in between 50th percentile and 84 percentile. And that would be another 34% under the 50 for 16th percentile. I just don't understand how to do that with the scores. So I don't know.
Yeah. Let me show you. The second percentile is 1720. So basically what they're saying is the 2%, 1720. Okay. 84th percentile, you can see that middle will be 50th percentile. That's 2 percentile. 68th percentile will be, 84th percentile will be 34 more. That's going to be 1990.
Yeah.
Okay. Okay. Now you kind of have to see that they're talking about this is, remember the Z score I was talking to you about? This is like the 0 Z score, the mean. Okay. This is like -1. This is -2 exactly, because not so they just approximated it. Okay. Remember 2%, 2.5%, and this is like +1. This is like +1. Okay.
Right.
58%. So even if you don't know the mean here, you can kind of see the difference between the first one and last one is 270. Okay. So actually, this is going to be, the standard deviation must be 90 then, because if it's 90 times 3, that would have worked out perfectly. Okay. So the mean is going to be 1900. This is going to be 1810. See, that works out well.
Yeah. Yeah, I do.
So that is actually, so if this is 34% here, right here on the right side.
Yeah.
That means this will turn out to be, the left side will turn out to be 16%. All right.
Yeah.
So 1810 is the number. Okay.
Yeah. Gotcha.
Okay. Yeah. Pretty tricky one. You know, you have to understand that they use 2 percentile instead of 2.5 percentile. You know.
Yeah.
So.
Yeah. I mean,
so you approximate it because there's no exact thing with probability statistics. You know, you just have to approximate it.
Right.
Well, actually, there is exact in probability, but in statistics, it's not. It's, you know, approximating anyway. Okay. Let's try number 19.
Okay. The data set contains at least 2 different integers, the range and the interquartile range. Interquartile. What was the interquartile range again? It was the okay, it's like 3/4 minus the something like that. I'll say D.
For D?
Yeah.
Yeah, you got it right. Range is like maximum minus minimum. Interquartile range is like 75th percentile minus the
25th percentile. I don't see how you could get yeah, there's no way.
Yeah. Okay. Now let's try 20.
Okay. Aren't they equal?
No.
No.
Good equal?
Yeah, that's what I have.
Yeah, me too. Perfect. All right. How about 21, the one at the bottom?
Okay. A is greater. Oh, I don't know.
A is correct. That's correct.
A?
Yeah, makes sense.
Yeah, I got 68,
Yeah.
but
Hmm.
is that right? A is greater.
Yeah.
How? It's just I'm not sure. I mean, I understand,
Hmm.
but I just don't see. What if the standard it doesn't tell you a minimal standard deviation? So it's like, how do you know? Like if you add 3 to 12, it's 15. If you take away 3 from 12, it's 9. So if it's less than 3.
If you draw the picture,
Yeah.
12 is right in the middle. Okay.
Yeah.
9 on the left,
Mhm.
15 on the right. So you automatically know this one has 68%, right?
Yeah. If it's the maximum, which is 3.
Right? Because it is
Right.
3, right? Now, if it's less than 3, so if it was less than 3, it has to be 68% or more. Okay.
Mhm.
If it's less than 3, what if it was 1? Then it'd be like almost like 99% or something, The division was 1. Get
Yeah.
it? So pretty much you can say 68 is the lowest possibility. So 68 is bigger than
Oh,
60%.
I see. Yeah. Okay.
Okay?
It's the lowest possible.
Kind of
Okay.
like logic there.
Yeah.
Yeah. Yeah, try 22.
Okay. A is better or bigger.
You're right. Is it here?
Yeah, it has to be bigger because, yeah.
Okay, cool. Okay, all right. Yeah, 23.
Okay. Can you go up a little bit?
Yeah.
Let's see. The graph represents normally distributed. Shaded area is 68%. Okay. So the mean is always in the middle, right? Or is it the median that's always in the middle?
Okay.
Mean. I guess they're equal, right?
Mm,
They have to be equal.
no, I can't.
No?
No.
Because you got one standard deviation above is 34%, right? And it says that in the shaded, that's 68%. Is it D?
Yeah, it is D. You can tell.
Because I thought it was
Because,
always one. If you go one standard deviation above the mean,
yeah,
you're going to be in 34%.
yeah, but do you know if it's symmetric? If that middle point is right, 550, how do you know that? Just because it looks like it doesn't mean it is.
We don't know if
Huh?
it's really in the middle.
Yeah, that's the thing. Okay, so we shouldn't assume it. Okay.
Okay.
Yeah, 24.
X and Y. Is a greater mean than X. We don't know that. Y has a greater standard deviation than X. That would be false. B.
B only?
Yeah.
No.
Hmm.
B, when you're talking about the second one, no, the second one is not. So you can see that B is way more spread out, right?
Yeah, so it's a greater standard deviation, right?
So definitely, okay.
Yeah.
Also, B's middle seems to be on the right of the middle of A, right? So definitely C is true, okay?
Yeah. Yeah, I see what you're saying. Yeah.
So A and C are definitely true.
Yeah.
If you look at B, we don't really know about B for real.
Okay.
Okay. Okay, we cannot really tell. It's here, let me draw the picture and show you. Okay. So why is 2 standard deviation be way spread out? See, X's standard deviation is not so spread out, you know?
Yeah.
Get it?
Uh-huh.
And actually, those should be equal. We didn't.
Wait.
So the outside 2 standard deviation, you have only 2.5% and 2.5% here. And this is 2.5% here, 2.5%. So you're comparing the same thing here. This should be, this is actually equal, right? It shouldn't be greater.
Oh.
Get it?
Yeah.
No?
I don't. You kind of
Like
cut
for
out
example,
there.
it's like the SAT and ACT, you know, like the
Uh-huh.
this is 24. Let's go back all the way.
Yeah.
So the chance that you would have outside of 700 and 300 are about the same as outside of, let's say, this is 34 because it's 5 more and 14. Okay.
Okay.
So that's 2 standard deviations. So the chance that it's outside of that 14 and 34 is the same thing as chance that it's outside of 300 and 700. So that's what this question is really asking.
Okay. I see.
Right?
Yeah.
Right. Tell me when you feel burnt out, we can go to a different topic or we can do more.
Yeah. We'll do one more of these, I guess. The outcome of the standardized test is integer between 121, 151, and 200. The percentiles of 400 test scores are calculated. .400 scores. And the scores are divided into corresponding percentile groups. Minimum number of integers between 151 and 200, inclusive, that include more than one percentile group. The minimum number of percentile groups that correspond to the number to score. How on earth do you get this? What? The outcome of a standardized test between 100 inclusive. Percentiles of 400 test scores. Calculate the scores. The minimum number of integers between the inclusive that include more than one percentile group. I don't understand. I don't get this at all. How do we determine the number of percentile groups? I mean, B, is that even possible? How can you, the minimum number of percentile groups that correspond to a score of 200? I mean, that's
let me see.
Only one score that could get that.
Okay. So 151 to 200.
Yeah.
Okay. So there are 50 numbers. Okay.
Mm-hmm.
So, sorry, no, 50 numbers in between, and that's 400 test scores. Okay. So bottom 4 would be 1%. Another 4 would be another 2%. Another 4 would be another 3%, like this, all the way to each 4 will be, like its own percent, right?
Mm-hmm.
Get it?
I think my brain's fried.
Okay, but this one is a very hard one to explain.
This is getting a little too abstract for me.
Yeah, these are pretty crazy. Okay, if everybody got the same score,
yeah,
let's say if everybody got 200, you would have everyone's at that point, and now then the minimum number of percentile groups would be 1. Okay. Because everybody got 200. Right.
Yeah.
So B's answer for B would be 1, right?
Right.
Okay, and then for 25, it's a 4. I should have said 8. It's 8. There's 400 of them. 400 divided by 50 is 8. I should divide by 100. Yeah. So every group has 8. That's what you can look at. Okay.
Mhm.
Now, the minimum number of integers between 150 and 200 inclusive that includes more than one percentile group. It can be interpreted in different ways. That's what's throwing me off too.
Yeah,
Even if
this
they were
question
if
is
they were
very,
evenly distributed, yeah, if everything was evenly distributed, there'd be 8 scores on each percentile. Okay, if so, every score will have like 8 of them, right?
how'd you get the 8?
So because 400 divided by 50 is 8.
Okay.
Okay. So if everybody got a certain score,
Okay.
but this can also be C. What if everybody got 200? Right? Minimum number of integers between 151 and
I guess they could be equal, huh?
then if everybody got 200, the minimum of not personal, that would be 1 for the right
Mhm.
and 1 for the left. What's wrong with that? Inclusive. The 200 would have all the percentile groups. Yeah, I think this you should not. This can be ambiguous. This can be C. I can see why it could be. Yeah, don't worry about this question. It's messed up. Yeah.
Mhm.
Let's try 26. Oh, if you want to stop, we can.
Yeah, let's stop doing these. I need a break from these. These are
Yeah, can't take any more than
ridiculously
that. Yeah.
hard questions.
Yeah. Let's stop this.